Okay, last time we left off, we were with this particular exercise. I'm going to try and do, oh, it's actually down here. That's where I should go. Slideshow. So we were looking at this particular exercise, and we could have done this in a wide variety of different ways. So I have 5 assignments. I want to figure out if I pass my assignment grade is a pass or not. And then I want to also print out the result. No matter what, I'm going to print out the result. So here would be one of those things. I could, for each assignment from I from 0 to n, so I have 0 to n assignments. I could also have something like I had last time, which is counter is equal to 0, increment my counter each time. They all work. So for every assignment between 0 and n, there's n assignments. Add the value for assignment I to some kind of sum. Now let's add this in there. Sum is equal to 0. Variable sum is equal to 0. If at the end of all of this, notice I'm being lazy. You could argue not to do this. If the sum is greater than or equal to 250, return true, or say print let's do this instead. Print, and I'm going to put quotes around it. And I'm done, right? I notice it was very intentionally vague in certain parts. What do I mean by print out whether I passed or not? Do I just return true? Do I return false? Do I have a message that I print out? What does it even mean? So I could have done this a variety of different ways. And if I am vague, ask. It's okay, especially if it's going to help other people by you asking the question. Uh, so the real sign that you should be looking for is, can I resolve ambiguity? Is it in the question somehow? Do I need to read the question again? And if it's not clear, you can ask. There is no harm in asking. In fact, I have less respect for people when they don't ask. Asking shows that you're thinking through. Not how do you do it, but when you say return or indicate that they passed or not, what kind of indication do you want? Right? Is it a printing statement or is it a return false? It also notice, since I could have written this about 40, 50 different ways, it's really easy to detect cheating, both for pseudocode and for actual code, because everyone's going to do it in a different way. Even if you get the same answer, you get there with a different approach. Like a math problem doesn't look the same for each individual person either. And the pseudocode is not designed to be one way of doing it and there's only one right answer. It is a tool to help you think. So we have lots of valid solutions, lots of valid approaches. They're all good. I'm not picking on people to get the right answer. I'm trying to get you to think about how to approach the problem, and there's levels of right? There are ways of doing this that are completely and utterly wrong, and there are solutions that are better than others. There are solutions that work but not that well. That is what we're looking at. We're not looking at what right or wrong. It's not binary, actually Boolean. It's not only it's pass or fail or anything like that. We have levels of quality that we have with our code, and that's why we do one of the reasons we do pseudocode, because it allows you to think through your approach in a very lightweight way. All right, I wanted to go over coding survival tips. Now, this is just a little aside before we get to flowcharts, because we looked at pseudocode briefly. Pseudocode, I'm not enforcing any kind of formalized approach. There are formalized approach. I'm not enforcing it. It should be English, point form, have a particular structure so you see what's in the loop, what's in the if statement by indenting. So you indent to show that it's in the loop or in the if statement. And it should be clear. Before we go, because I know you're going to be coding soon with Scratch and with C, I want to go over some survival tips that you can refer to again later. So let's go over those survival tips, and hopefully it'll make some sense, but if it doesn't right away, hopefully it'll make sense as soon as we get to code. So here's number one. That's why we go over all this. Before you code anything, you should always have a pen and paper around you. right? It's your towel if you like Hitchhiker's Guide to the Galaxy, right? Every coder should have a pen and paper. Now you don't have a towel, you have a pen and paper, right? Pseudocode allows you to test things in advance in a lightweight way, without having to commit and spend hours typing something out and then trying to debug it later. It allows you to see the big picture rather than the minutia. Okay, number two is that we have steps on a journey. So the pseudocode allows you to do the high level view, and then later on, if there's something there that you need to expand more, figure it out later. This is equivalent to the pay the cashier problem that we had, right? Um, if I have a problem, I want to do little mini steps, maybe afterwards. I want to do one step at a time. I won't do the whole thing all at once. The kiss of death always ends up being, I'll have people not think through the problem. They will write all the code all at once, and unfortunately, I have that. That's my natural tendency, and I have to fight myself every single step of the way. I want to write all the code and then test it. The worst thing I can do. You do a little bit, test, little, not extensive testing, just enough so that you don't have 4,000 compilation errors. You do a little bit, you fix it, make it work. Do a little bit more, fix it, make it work. Not a big batch at the end. So, little steps, one problem at a time, and then if you have to put in little fake, we'll talk about to dos at step 5, right? That's fine. But you do one little bit at a time. You don't try and do everything and then check to see if it works. It will not work, and you will spend about 5 times longer doing it. So it's, if you're putting together a bookshelf, you do the next 4 instructions, or you're putting together the Lego set, you do the next 4 instructions. You don't read the entire instruction booklet and then just start, right? You do a little bit, move on, a little bit, move on, a little bit, move on. Comments are your friend. Comments are not for me, although they do help me. You write comments for other people who understand your work, like the TA, so they can give they don't have it. You want to give them an excuse to give you points. Your comments, even if your code doesn't work or work as you expect it to, your comments can get you points. So, not comments for comments' sake, but a good comment tells you what you're trying to get across, even if you wrote it wrong. It makes things a lot clearer. But more importantly, future you is the person that benefits the most. The comment means that when you read it again the next time, you will understand what you're trying to do. I don't know how many hours I've spent rereading my old code to find out, like, what was I thinking? Was I drinking at the time of writing that? Like, it's terrible. You write things, sometimes you're half asleep writing it. You want to be able to say what the heck. The comment helps you figure out what you're trying to do there, because you can spend a lot of time rediscovering why you did something a particular way. I know I have. All right, testing. We're not going to go hardcore into testing, but this is a cult essentially. Test-driven development. There are people that program that is they eat, sleep, and breathe this stuff. The idea is when you're writing your code, you should always be worried about what possible weird cases we have. I'm trying to find the smallest number in a bag. What if there's no numbers in the bag? I'm going to go to Tim Hortons. What if I don't have any money? What if I'm the only person in line, not the last, so I don't stand immediately behind somebody? What if I didn't bring my wallet? Right? Things you want to think about, all the weird edge cases. That is the sign of someone that really understands what they're doing. You want to think through the test cases. You want real tests that you can actually test. We'll look at asserts later to make sure that your code works as expected. Because hoping it works means it doesn't. Coding does not work by accident. And so you want to have your code tested before you move on to the next part. And you can always add more tests. Your to-do lists go to the question 2 part. If I have a really big problem, like how do I figure out, how do I make the paint program, right? Or that's maybe a bit too big. How do I, the pay cashier subroutine for Tim Hortons? What I want in all of these examples, anytime I have something that's really big and it's too big to just put in one step, I want to have another algorithm somewhere else. If I'm writing code, I want a function, or I'm going to say, I'm going to do that later. and you put in just enough there to make your code work, but you don't actually solve that problem. You say, to do, I will get to it later. I will write that other code later. I'll put in a fake number for right now and go from there, right? If you're trying to figure out what your GPA is, you don't have all your grades yet at the end of term. What do? You put in a fake number for your last assignments, calculate your GPA, see approximately where you are. It's not the actual answer. It's close enough, right? It's close enough to know approximately where you're going. And what you want with these to-dos are, you're going to get a wrong result from it. You don't expect it to work. That's fine. You have something there to let you test and compile your code and make sure that everything's running before you move on. So, for example, if I want to find the minimum number in a list of numbers, I could sort the numbers, take the first number, right? It's sorted, meaning it goes from the smallest to the largest, and then I just take the first number. Well, sorting actually is a really, really, really big, problem. It's actually more difficult to do than you might expect, at least doing it well. But I just put a to-do saying, yeah, I'll sort it, and then I'll take the first number. And then later, after I've done the rest of it, I go back and figure out how to sort things. If you are getting errors, this is why you do little bits at a time. If you get errors, it will cascade. See, code starts from the top, goes to the bottom, and as it's going along, if it gets an error, it will cause other errors later on. It's think of like Christmas lights, right? If you have back in the bad old days when you had a broken bulb in a Christmas light, the entire light string would break. Or if you're looking at electrical wiring in your house or any number of other things, right? If you have an error early on in the process, everything after that is broken. That's the same here. So if I have an error early on, everything's broken. What I want to do is fix the common culprits, which is normally these things here, this missing curly braces and semicolons in C code, maybe checking for your includes. You check a line or two above the very first error, see if it can find the error, fix the first error first, recompile. Fix the first error first, recompile. You will get 400 errors, and you'll find out it's caused by two things. You fix those two things, everything else works. The last thing you should do is try and fix the last error, because it's a cascading error. You're fixing something that's not broken because it's saying it's broken. The first error was causing everything behind, but after it to break. Okay. This is something that people don't think about, and they sort of throw up their hands. If you do not know why your code doesn't work, brute force is just checking what the output is, figuring out what's going on in your code methodically. Put something that outputs to the screen somewhere in their code, see if it works. So, in case you didn't know where this particular reference is from, this is Monica Geller from The Tale of Which So Friends. I'm sure many of you have watched it. And she's trying to figure out what a particular light switch does. And she kept on making holes in the wall trying to figure out where the light switch is hooked to. She has no idea what that light switch does. I won't give away the ending, but many of you will know what that ending is. Her approach is reasonable, and she actually has a really smart approach. She plugs in blenders into every single one of the wall sockets in the apartment, and turns on the switch to see if any of them turn on. Right? That's the kind of thing we're doing. We will put in a print statement somewhere to see what the data looks like, and it allows us to deduce where our error is. Why is that number negative? Well, let's figure out what that value is on line 497, right? Oh, it's not working on line 497. Let's go a bit before that. It's methodically breaking down a problem and trying to figure out where the error is caused, where it starts. You can't just look at the end result. You put measurements along the way. Speaking of which, we'll be using breakpoints later on. And so a breakpoint allows you to stop your program at that particular line so you can look at what the data looks like. We will go over this in excruciating detail, especially once we start looking at Visual C++ and we've done some hex. It allows you to stop your program, look at what things look like, and debug things. Figure out what the problem is, because you will have problems. So I'm going to stop there, and we're going to do the flowcharts video first, but I thought I'd point that out. So thank you, everyone, and you'll see me in the next video.